Hello, my dear student. In this video, I'll begin to illustrate to you also a different traversal step, which is all about the bread first searching. So in our bread first searching class, it is different actually because of course, for the bread first searching is actually, the process is different than the depth first search that we were able to finish in this separate video. But here then, let me run through the BFS that we will begin to utilize the Q representation. What kind of Q representation? It is actually a simple Q representation, meaning that you will begin to work on with the you have to work on with the level by level if you are working on that um via trees, like the left to right traversal. Okay, this is how you will work on in this. So first thing first, you have to go ahead and insert a into your queue. It will be in queued in queue a, and then afterwards you have to get the adjacent of a. What will be the adjacent of a? That is actually connected to c, d, b. So better that you will begin to go ahead and work on it from left to right so that we will begin to understand it better. Okay, the same with your DFS also, that's fine. So with regards to um this one, you can also work on with B, C, D. That's fine. I don't have any problem in terms of that one because this that is still level by level. However, we will begin to work on it using actually we'll begin to base here we'll begin to base here using the left to right if we are working if we are working in terms of the traversal in our three data structures. We'll begin to follow that structure. Okay, just remember. Actually, class, just to make it correct, as what I have also validated that the left to right principle will be pretty much be applicable in terms of the three data structures. But here then, in order for us to have a uniform structure, it could have been better that we will begin to work on with sorted manner so that we can achieve the same exact value. Okay, so we can have B, C, D instead. Now afterwards, you have to get here the BFS, which will become A, since that has been we're able to work on that already. Now since we're able to NQ A, you have to NQ also in the next step the adjacency of A. What will be the adjacent of A earlier? That is B, C, D. So all of this will particularly be inserted into the rear end and into the as what we have as what we do have from the rear end position. We have B, C, D, so it will become A, B, C, D into your queue right now. So you just have to specify in queue B, C, D. And then in terms of this one, you don't have to make it step by step, like in queuing B, in queuing C, in queuing D. It's fine that you will begin to work on that as like this so that it will be better for you for the benefits of your time as well, since the examination will takes time, will takes only 2 hours and 30 minutes, and I know that you can't finish the examination since it is really extensive. Now in terms of this one, you have to check the adjacency of you cannot check the adjacency because of course you cannot access yet the letter B. What you will need to do, you have to make sure that you will begin to remove A first. Okay, we have to remove that A so it will be dequeued into your queue. So since that has been you specify the QA, so the front end will be B. So since the front end is B, so therefore you have to check the adjacent of B. What will be the adjacent of B? The adjacent of B actually is A and D, but considering that, you have to also update here. So sorry, the BFS earlier, you will need to make sure to update that into A, B, C, D. Okay. Now, right now, since we're able to insert, I mean, um, get the adjacent of B, C, D, you have to assess as well what will be the element that you can insert into your queue. You will not be going to revisit actually those visited element um or visited you don't have it's actually not necessary to revisit those kind of um element. So A has been visited, or I mean that was already in your um BFS, so therefore we will not be going to visit that again. Okay. Con- D is not already D has been inserted into your BFS, considering that we're able to um insert that into your BFS, or it has been visited, so therefore we cannot do we cannot do anything right now in this particular stage. So since you cannot do anything, you just have to the QB in order for us to search as well for um C element. Now, by checking the C element, you have to work on this here. What will be the adjacent of C? There will be A, there will be E, there will be F. So therefore, by checking that one, since the adjacency has been you were able to check the adjacent, A has been inserted into your BF, has been visited. E was not, and F is actually not. We're not able to visit that one, therefore we can definitely include that in our queue right now, so that it will become C, D, E, F. So therefore, what will gonna happen? You have to make sure to indicate here that you were able to in-queue E and F, and then you have to make sure to put here your BFS update. It will become A, B, C, D, then E, F. Then afterwards, since we're able to do checking, I mean updating the BFS, what will gonna happen? You just have to also make sure to dequeue also for the operation of the element of C, so that you can also visit the another element. So right now the front end will be D, and we're able to dequeue C. And then what will be the adjacent of D? The adjacent of D is actually um A, there will be B, there will be E and G. So considering the fact that A has been visited, B has been visited, and E has been visited, so G we're not able to visit that yet. So we can insert that in our queue. It will become in queue G, and then after in queuing G, you have to update your BFS into this A, B, C, D, E, F, G. After in queuing that one, since we're able to visit the adjacent of D, you have to perform the deletion for G. So therefore, you just have to indicate here that you were able to successfully dequeue D, and you have to identify what will be the adjacent of E. So the adjacent of E will be C, D, F, G, considering the fact that we're able to visit already C, we're able to visit D, we're able to visit F and G. So therefore, there's we cannot do anything at this particular stage. So what will gonna happen? You have to make sure to delete that E right there, and we'll proceed with F. So you have to indicate that you were able to dequeue successfully the E, and then check the adjacent of F. And what will be the adjacent of F? Considering that in our graph, the adjacent will be C, E, G. So just make sure to put that right there. So considering that in your BFS, we're able to visit C, E, and G, therefore we cannot do anything then. Now, we have to dequeue the F right now, and after dequeuing F, we can definitely check the adjacent of G. What will be the adjacent of G? That is actually adjacent to DEF, and considering the fact that we're able to visit DEF, so therefore what we're going to do, we just have to dequeue that G, and then of course, since your queue right now is actually empty. So you just have to update here that the BFS is actually A, B, C, D, E, F, G. So that's actually the that is absolutely the operation of BFS is actually pretty much really so simple. I hope I am hoping that you were able to understand the process for the BFS traversal. So make sure to work on it as like this into your examination, so that since of course if you were able to make it wrong, you know what will gonna happen into your scores. Thank you so much everybody, and we'll be going to discuss already the separate video all about the spanning tree, which will start from the Prim's algorithm, Kruskals algorithm, and then there will be Borovkas, and then there will be the reverse delete algorithm. Thank you so much everybody, and goodbye.